Okay, good afternoon, everyone. We're going to go over this lecture for basic differentiation formulas for our Math 215 Applied Calculus class. First, we'll go over the derivative of basic functions, then we'll go over basic differentiation rules and the derivative of polynomials. So, if you recall, one of the interpretations on Monday's lecture was that f prime was the slope of the tangent line to the graph of a function at a point x comma f of x. If the function has a graph who's a line, then the graph always coincides with this tangent line, and the derivative of that function will just be its slope. So the derivative of the function mx plus b is just m. The derivative of any constant is 0. If fx is a constant, f prime is 0. So here's an example. If at time t, remember our example 2 in Monday's lecture, t is time in seconds, and h of t is the height of an object. Then h prime of t is the velocity of the object after t seconds. And if the height is constant, let's just say instead of dropping that eraser, it remained on top of the CN Tower in Toronto at 450 meters, then the object would remain at rest. In this case, the derivative of that function, the derivative of the height function, the velocity function is 0. This means the velocity of an object that is at rest is 0. So it makes sense. An object's not moving, right? It doesn't have any velocity. Now, here we're going to go over how to differentiate an exponential function. Let's start with the function b to the x for some positive real number. If you look at f prime of 0, limit h goes to 0 with f of h plus f of 0 over h, that's just the definition. It's the same as limit h goes to 0 with b to the h minus 1 over h. F prime of 0 is the slope of the tangent line to the graph of y is equal to b of x at this point, 0, 1. And so you might have been wondering how the number e was defined earlier. Well, it turns out the number e is defined by this formula. It's defined as the number for which e to the h minus 1 divided by h is equal to 1. So where this means it's defined as the number for which the slope of the tangent line to the graph of this exponential function at the point 0, 1, all exponential functions cross this point, has slope equal to positive 1. Here's a graph of the exponential function, as you can see. This is the exponential function, has the same shape as all exponential functions, but it has a special property that when you look at the tangent line at the point 0, 1, and all exponential functions pass through this point, the slope of the tangent line at that point is equal to positive 1. Here, okay, so how about the derivative of the exponential function? If fx is e to the x, then f prime is this ratio and this limit of this difference quotient. And it's the same, actually, as limit h goes to 0 of e to the x times limit h goes to 0 e to the h minus 1 over h. It turns out, because this limit here is 1, this whole limit becomes e to the x. So the derivative, we find the derivative of e to the x is itself. Okay. So here's a table of some functions that correspond to derivatives. In particular, derivative f of x is 1. Derivative of a constant is 0. Derivative of x to the r is r times x to the r minus 1. Derivative of e to the x is e to the x. Derivative of ln of x is 1 over x. Derivative of sine is cosine. Derivative of cosine is minus sine. Power rule, if h of x is x to the r, then h prime is r x to the r minus 1. We've seen it in the table above. And sum rule, derivative of the sum of functions is just the sum of their derivatives. Difference rule, same thing, but with difference, the derivative of the difference of two functions is the difference of the two derivatives. Constant multiple rule, if h of x is c times f of x, the derivative of this function is the constant times f prime of x. So constant times the derivative of the function. We can use these rules to differentiate polynomials. Regular of p of x is this function, it's polynomial. P prime is just basically, you just use the power rule, take each of these exponents down, place it in front of each of the coefficients. So take n down, place it in front of an, take n minus 1 down, place in front of an minus 1, take n minus 2 down, place in front of an minus 2, put 1 down, place in front of 1, okay, that's x to 0, right? The root of a1 x plus a naught is just, 0 is just a 1. And just add them all. So here's an example. Let's say we were asked to differentiate the function x cubed plus x squared minus 3x plus 1. In that case, the root of that function would be 3x squared plus 2x minus 3. This 3 comes down, you subtract 1 from the exponent. That's what the power rule says. 3 comes down, and you replace the exponent with the exponent minus 1. 2 comes down, you replace the exponent with the exponent minus 1. And the root of minus 3x plus 1 is just minus 3. So what these, so again, I'll summarize again. The power rule says the exponent comes down and you replace the exponent with r minus 1. That's if you're differentiating x to a constant power. And all these other rules, sum rule, difference rule, and constant multiple rules, just means that you can differentiate a polynomial term by term. And in particular, you just leave the constants in front of each of these power functions again.